Okay, girls, let's have a look at this challenging question from one of your exercise. It says prove this is equal to that. Okay, let's now look at these two individually. Okay, so they want us to prove, let's rewrite this in terms of factorials. So that's n factorial over n minus r factorial. Yeah, that's exactly the same as that. Over, now r factorial is equal to, we need to prove this is equal to, now let's expand this out. Notice how we've got n and it's n minus r. So the top still stays the same, but for the bottom, you know how we did n minus r for the bottom? Then this would be n minus that. So you would write it like this, bracket n minus bracket n minus r, bracket, bracket, factorial, okay? So keep that in mind, over n minus r factorial. So we need to prove this is equal to that. So let's work from this side and let's try and get to this side. Okay? Let me rewrite this out. First of all, let's simplify this fraction. So remember, when you have fraction divided by fraction, multiplying the inside goes to the bottom. So that's r factorial over n minus r factorial, and multiplying the outsides go to the top. Okay, so we've got that. We've simplified that and we get that. Now we're trying to get from here to that. So as I can see, I've got these two, but I've got an r factorial. There's no r factorial here, and I need that. But the top is just n factorial. So here's what I'm going to do, and here's your technique. Because I need this on the top, for my expression here, I'm going to times the top and the bottom by that. In this case, will be 1 over bracket n minus r bracket bracket x factorial. If I times anything to the top, I must do it to the bottom. And let's see where I go with this. Okay, so if I do that, if I multiply these two, I'm going to get exactly what I want, n factorial over n minus r factorial. Now with this one though, let's put these two together and see what happens. So that times this means that's just going to go on top, r factorial, n minus r factorial, all over that. Okay, it looks quite complicated. We've got the top, but we need all of this to somehow be simplified to that. Okay? Well, let's have a look. Let's have a look at just the bottom here. Let's specifically look at the inside bracket here. We can actually simplify that. What's n take away n? 0. And what's minus r? Just r. So what I have is r factorial over that, with the remainder on top still exactly the same. Can you see where I'm going with this? What can I do to the bottom? Look, they're the same. So if I simplify that, that gives me exactly what I want there. This is the same, n factorial over n minus r factorial, and the bottom, n minus r factorial, which is exactly equal to the right hand side. Okay, so this is how you do this problem. The technique is multiplying the top and bottom by whatever you need on the other side. Alright? Okay, girls, let's have a look at this question now. It says prove that is equal to that plus r that. So as usual, let's rewrite these expressions in factorial. So this would be n plus 1 factorial over that take away that factorial. In this case would be n plus 1 take away r factorial is equal to, that's just your standard definition of a factorial, plus r times n factorial over n take away that factorial. So n take away bracket r minus 1 bracket factorial. Okay, so we need to prove these two added is equal to that. Okay, so let's work with this side this time, because we've got the addition on this side. Okay, so I'm going to write the first one as it is, but if it says r that, means rn over. Let's simplify this. N take away r, minus 1 becomes plus 1. So we have this at the bottom, okay? Now we want to try and put these two fractions together. Now, here's a note. Can you see this is n minus r, this is n minus r plus 1? So before I put these two fractions together, think of this, for example, as 2 factorial, and think of this term as 3 factorial, because it's plus 1 to that. So in other words, this is 2 times 1, this is 3 times 2 times 1. So if I want to put these two fractions together as a one common denominator, so obviously it would be n minus r plus 1, which is the bigger denominator, what would I need to multiply this fraction by to have that denominator? What does this have that this doesn't? Obviously times 3, right? Or in this case, you would have to times the top and bottom by this term. That's like your 3. So in this case, I would have now then n factorial times that whole thing. Okay? Without the factorial. Remember, we just need the 3, not the whole thing. Plus rn factorial. Okay? Let's see what happens to the top. So the bottom stays the same. If I multiply this, that's n factorial times n. So I'll just write it as it is. So n dot n factorial. The dot means you're multiplying two products. Okay? Now that times that is minus rn factorial. That times that would be just plus n factorial. And we've got the plus rn factorial. Can we simplify things here? Yes, I can. Minus rn factorial plus rn factorial. Okay. Can I do anything with these two? I could. There is a common factor. What's a common factor? N factorial. Factorial n plus 1 over that. Okay. Remember, I'm trying to get from here to this. We're very close. We got the bottom, but our top looks slightly different. But can you see how this is equal to just n plus 1 factorial, which is the answer? Yeah? Because remember, n factorial is just your n times n minus 1 times n minus 2 and so on. Okay? But if you're multiplying n plus 1 in front of this with the rest, that expression is the same thing as n plus 1 factorial. Okay? So that's why I can just write this as that. Okay? So this is how you prove that is equal to that. Okay? I hope that makes sense. I highly suggest you give those two questions a go on your own after looking at that, and get back to me with any questions you have in that exercise. All right, thanks, girls.